Hello, in this lecture we will find the value of 2 times AP, or the size of 2 times AP. Actually, you can see in the picture triangle ABC. The size of AB equals to 90 units. The size of AB equals to 90 units. The size of AC, or the size of side AC of the triangle, equals to 70 units, and the size of side CB of this triangle equals to 50 units. And you can see in the drawing a circle. The center of this circle is point P, and actually the point P is situated on side AB of the triangle, and actually the circle has 2 tangents. Side AC of the triangle is tangent to this circle at point, we will call that point point O, and or we can say that the touching point between side AC of the triangle and the circle is point O, or again point O. Side AC is tangent to the circle at point O, and also side CB of the triangle is tangent to the circle at point, we will call that point point E. Or the touching point between side CB of the triangle and the circle is called point E. And in the next step we will connect points O and P together by a straight line. So actually line PO is the radius of this circle, because it starts from point E, from point P, the center of this circle, and ends at point O on the circle. For that reason it is defined, OP is defined as the radius of the circle. We will mark line OP as R, abbreviation for the radius of the circle. And in the same way we also will connect points P and E together by a straight line, and so actually PE is also the radius of this circle. For the same reason, because PE starts from the center of the circle, that is to say from point P, and ends at point E on the circle. For that reason, PE is the radius of the circle. So we actually we draw two radiuses of this circle, and actually we have a rule that a radius and a tangent to this radius are perpendicular to each other. Okay, so the size of this angle POC, is equals to 90 degrees, because actually the radius PO is perpendicular to the tangent of this circle, that is to say to AC. So the angle POC is 90 degrees, and also in the same way angle POA is also 90 degrees, for the same reason, because this radius, that is to say PO, is perpendicular to the tangent AO or AC. So PO is perpendicular to AO, that is to say angle POA is equal to 90 degrees. Again, in any circle, a radius and a tangent to that radius are perpendicular to each other. Okay, so, and for the same reason, PE will be perpendicular to CB, the tangent to this circle. So angle PEC will be equal to 90 degrees, because the radius is perpendicular to the tangent of the circle, and for this reason also angle PEB will be equal to 90 degrees, because the radius is perpendicular to the tangent of the radius. So the angle PEB will be 90 degrees, and the angle PEC will be also 90 degrees. Okay, again, in any circle, a radius and a tangent to this radius are perpendicular to each other. Okay, so PO is perpendicular to AC or AO, and also PE, the radius of the circle, is perpendicular to the tangent, perpendicular to CE or CB. So PEC is equal to 90 degrees, and also PEB, angle PEB is equal to 90 degrees. Okay, so I will write this rule down. So the rule is that in any circle, the radius and the tangent to that radius are perpendicular to each other. Okay, again, all one states that in any circle the radius and the tangent to that radius are perpendicular to each other. I can also draw a picture. So if we have, for example, a radius, let's call it R, then this radius is perpendicular to the tangent to the radius or to the circle. It is the same because the tangent to the circle is also tangent to the radius. So let's call that tangent to the radius t. Then this angle will be 90 degrees, and also this angle will be equal to 90 degrees. So again, in any circle, the radius and the tangent to that radius are equal to 90 degrees, or the radius and the tangent to that radius are perpendicular to each other. Okay, so this is the first rule. That you should remember. It's true in any circle. A radius and the tangent to that radius are perpendicular to each other. That is to say, the angle between the tangent and the radius will be 90 degrees. Okay, this angle is 90 degrees, and also this angle is 90 degrees. Okay, and we will also draw a perpendicular from point C to side AB of the triangle. So from point C, we will draw a perpendicular to side AB of the triangle. Okay, so actually, and we will call the touching point between the perpendicular to side AB, point M, capital M. So actually angle CMB will be equal to 90 degrees because CM is perpendicular to AB, and also of course angle CMA will be equal to 90 degrees because CM is perpendicular to side AB of the triangle. Okay? CM is perpendicular to side AB of the triangle. Okay? So let's define angle CAP or CAB. It is the same. Let's define this angle as angle alpha. Again, angle CAB or CAP, it is the same, is defined as alpha, and we will define angle ABC or ABE as beta. Okay? Angle PBC or ABC is defined as angle beta, and angle CAB or CAP is defined as alpha. Okay? So in the next step, we will focus on triangle OAP, triangle OAP, and triangle CAM. As you can see, triangle OAP is a right triangle because angle POA equals to 90 degrees. For that reason, triangle OAP is a right triangle, and also triangle CAM is also a right triangle because angle AMC equals to 90 degrees. So both of those triangles, triangle OAP and triangle CAM, are right triangles. Okay? So, as you know, in a right triangle, if we focus on triangle OAP, sinus alpha equals to the side that is in front angle alpha, that is to say OP, over the hypotenuse of triangle AOP, and the hypotenuse of triangle AOP is AP. Okay, so sinus alpha in triangle AOP equals to OP over AP, or the ratio between the side that is in front of angle alpha divided by the hypotenuse, that is to say AP, or sinus alpha in triangle AOP equals to OP over AP. Okay, so from one side, but if we also now focus on triangle CAM, that is also a right triangle. In triangle CAM, sinus alpha will be equal to the side that is in front of angle alpha. The side that is in front of angle alpha in triangle CAM is CM over the hypotenuse of triangle CAM, and the hypotenuse of triangle CAM is AC. Okay, so in triangle CAM, the right triangle CAM, sinus alpha equals to CM over AC. Okay, so in total we have the equation that sinus alpha equals to OP over AP, that equals to CM over AC. So we can rewrite this equality. So the first equation will be OP over AP equals to CM over AC. Okay, so I copied this equality, and it is actually the first equation, that OP over AP equals to CM over AC. Okay, so this is the first equation. In the next step, we will define AP as X. So AP equals to X. I write it here, that AP equals to X. And actually, as I told you in the beginning of the lecture, OP is the radius of the circle. So OP equals to R. OP equals to R. And also we know that AC, according to the data that we have in the question, AC is given to us. AC equals to 70 degrees. It is given us in the question that AC equals to 70 degrees. So we can write it down that AC equals to 70 degrees, 70 units. Okay? Again, we defined AP as X, AP equals to X, and OP, so AP equals to X, as you can see here, and OP is the radius of the circle, and AC equals to 70 units, okay? So I write that AP equals to X, OP equals to R, and AC equals to 70 units. So in the first equation we can substitute AP by X because AP equals to X. We can substitute OP by R because OP equals to R, and we can substitute AC by 70 units because AC equals to 70 units, okay? So we'll do it now. So OP equals to R, we'll substitute OP by R over AP. We defined that AP equals to X, so instead of AP we will write X equals to CM. We will leave CM as it is over AC. AC equals to 70 units, so we can substitute AC by 70. Okay, so we got that R over X equals to CM over 70. Okay, as I've already told you, we substituted OP by R, AP by X, and AC by 70. Okay, so we have the first equation, R over X equals to CM over 70. Now we will multiply both sides of the equation by X. As you can see in the picture, X equals to AP, so X that is defined as AP is a positive number, so it can never be zero, so we can multiply both sides of the equation by X. Okay, so here we will get that equation 1 R divided by X times X equals to R and CM over 70 times X equals to CM over 70 times X. Okay, again R divided by X times X equals to R, and CM over 70 times X equals to CM over 70 times X. In the next step, we will divide both sides of the equation by CM. Okay, we divide both sides of the equation by CM. Actually, as you can see from the picture, CM is the perpendicular to side AB of the triangle. So CM is a positive number, it can never be zero. For that reason, it is allowable to multiply both sides of the, to divide both sides of the equation by CM. Okay, so we get that R over Cm equals to x over 70. I'll repeat again. We divided both sides of the equation by Cm. So R divided by Cm equals to R over Cm. And Cm over 70 times 6, or divided by Cm, or it is actually Cm divided by Cm times x over 70. So Cm is cancelled because we have Cm we have Cm in the denominator, and we have also Cm here, so Cm is cancelled. So we got here that after Cm is cancelled, we got what is left is x over 70. So we have, again, we have Cm in the numerator and we have Cm in the denominator. So we can cancel Cm from this expression because we have Cm in the numerator and we have Cm in the denominator. So we can cancel Cm from this expression, and what is left is x over Cm. Okay, so we have the first equation, R over Cm equals to x over 70. Okay, so we finished with this side. Now we will go to the other side of the triangle, that is to say to sinus beta. And we will focus on triangle BPE. It is a right triangle. Triangle BPE is a right triangle because angle PEB equals to 90 degrees. This angle is 90 degrees so triangle BPE is a right triangle, and we also will focus on triangle BMC. Triangle BMC is also a right triangle because angle CMB equals to 90 degrees. Okay, so both of those triangles, triangle BPE and triangle BMC, are right triangles. Okay, so we can apply on them the function sinus beta, because both of those triangles consist angle beta. On both triangles, angle beta is one of those triangles. Okay, so actually sinus beta in triangle BPE, sinus beta in triangle BPE, in the right triangle BPE, equals to the ratio between the side that is in front of angle beta. The side that is in front of angle beta is PE. Again, in triangle BPE, the side that is in front of angle beta is PE, and we divide it by the hypotenuse of triangle BPE, and the hypotenuse of triangle BPE is equal to PB. Okay? Again, the hypotenuse of triangle BPE, the right triangle BPE, is PB, and actually, as you can see from the picture, the value of PB equals to AB minus AP. Again, the value of PB equals to AB minus AP, and actually AB equals to 90 units and AP equals to X. So the value of PB is equal to 90 minus X. Okay, again, the value of PB equals to AB, that is to say 90, minus AP, that is to say X. So the value of PB is equal to 90 minus X. Okay? So now we will focus on triangle BMC. We will focus on the right triangle BMC, and in this triangle sinus beta is equal to the side that is in front of angle beta, that is to say CM, because in triangle CMB the side that is in front of angle beta is CM, so it equals to CM over the hypotenuse of triangle CMB, and the hypotenuse of triangle CMB equals to CB. Okay, the hypotenuse of the right triangle CMB equals to CB. Okay, so it is CM over CB. Okay, so in total we have the equation that sinus beta equals to PE over PB, that also equals to CM over CB. So we will write down this equality, and that will be our second equation. So again, our second equation will be that PE over PB equals to CM over CB. Okay, again, the second equation is PE over PB equals to CM over CB. Okay, and now, as you can see from the picture, PE is equal to the radius of the circle. PE equals to R. Okay, so I write it here that PE equals to the radius of the circle, that is to say to R, and also PB, as I showed you 1 minute ago, PB equals to 90 minus 6. PB equals to 90 minus 6. I'll show you again. Actually, PB equals to AB, that is 90, minus AP, that is X. So in total, PB equals to 90 minus 6. Okay? And the value of CB is given to us in the question, and the value of CB equals to 50 units. Okay? The value of CB is equal to 50 units. Okay? So I repeat again, PE equals to R, the radius of the circle. PB equals to 90 minus 6 here, and CB equals to 50 units. It is given us in the question. Okay, so as you can see in the second equation, we can substitute PE by R, and also we can substitute PB by 90 minus 6, and we can substitute CB by 50. Okay, so we will do it now. Again, in the second question, we will substitute PE by R because PE equals to R, and then we will substitute PB by 90 minus 6 because PB equals to 90 minus 6, and we will leave CM as it is, and then we'll substitute CB by 50 units because CB equals to 50 units. Okay, so in total we have in the second equation R over 90 minus 6 equals to CM over 50. As I've already told you, I substituted PE by R, PB by 90 minus 6, and CB by 50 units. Okay, now we will multiply both sides of the equation by 90 minus 6. Again, 90 minus 6 is a positive number because the size of AB is 90 units and the size of AP is X, that is less than 90 units. So 90 minus 6 must be a positive number. So 90 minus 6 can never be 0, so it is allowable to multiply both sides of the second equation by 90 minus 6. Okay, so actually we will get that R divided by 90 minus 6 times 90 minus 6 equals to R. And CM over 50 times 90 minus 6 equals to CM over 50 times 90 minus 6. Okay, again I will show you. R divided by 90 minus 6 times 90 minus 6 equals to R, and CM over 50 times 90 minus 6 equals to Cm over 50 times 90 minus 6. Okay, so in the next step we will divide both sides of the equation by Cm. Again, we will divide both sides of the equation by Cm. Again, Cm is a positive number, it can never be 0. It is the perpendicular to side AB of the triangle. So it is allowable to divide both sides of the equation by Cm because Cm can never be 0. It is the perpendicular to side AB of the triangle. Okay, so we will get that R over Cm equals to 90 minus 6 over 50. Again, we divided both sides of this equation by Cm. So R divided by Cm is R divided by Cm, and 90 minus 6 over 50 times Cm divided by Cm, so it is Cm divided by Cm, is 1. Is Cm, we have Cm both in the numerator and in the denominator, so Cm is cancelled. So we left only with 90 minus 6 over 50 because Cm over Cm equals to 1. Cm is cancelled from this expression, but we left only with 90 minus 6 over 50. Okay, so this is our second equation, that R over Cm equals to 90 minus 6 over 50. But from our first equation, we got that R over Cm equals to x over 70. So I'll write it down. From the first equation, we have already know that R over Cm equals to x over 70. Okay, again, our first equation is R over Cm equals to x over 70. So we'll create the third equation, that is to say R over Cm equals to R over Cm. So the third equation will be R over Cm equals to R over Cm. Okay, so in the third equation we will substitute R over Cm by the value of R over Cm in the second equation, and then in this side of the equation we have also R over Cm, and we will substitute this expression R over Cm by the equation 1, the value of R over Cm in equation 1. Okay, so here in this side of the equation R over Cm We'll substitute R over Cm by the value of R over Cm from the second equation. That is to say, R over Cm in the second equation equals to 90 minus 6 over 50, and we'll substitute R over Cm by the value of R over Cm in the first equation, and R over Cm in the first equation equals to X over 70. Okay? Again, you can see it. We substituted in the first equation R over Cm by the value of R over Cm in the second equation. That is to say, R over Cm in the second equation equals to 90 minus 6 over 50. And we substituted R over Cm in this side of the equation by the value of R over Cm in the first equation, and R over Cm in the first equation equals to X over 70. Okay? So we substituted R over Cm here by the value of R over Cm in the second equation, and we substituted R over Cm by R over Cm in the first equation, the value of R over Cm in the first equation, that is to say X over 70. Okay, so we got the equation that 90 minus 6 over 50 equals to X over 70. Okay, so now we will multiply both sides of the equation by 50. We'll get that 90 minus 6 divided by 50 times 50 equals to 90 minus 6, and X over 70 times 50 equals to X times 50 over 70. Okay, again, 90 minus 6 divided by 50 times 50 equals to 90 minus 6, and X over 70 times 50 equals to X times 50 over 70. Now we can divide both sides of the equation by X. Again, X is actually AP. It is a positive number. It can never be 0. For that reason, it is allowable to divide both sides of the equation by X. So we will get that 90 minus 6 divided by X is 90 minus 6 divided by X, and 50 over 70 times X divided by X equals to 50 over 70. Again, I repeat again that 90 minus 6 divided by X equals to 90 minus 6 over X, and here we have X divided by X. So we have X in the numerator, and we have also X in the denominator. So X is cancelled, and we left only with 50 over 70. But we know that 50 equals to 5 times 10, and 70 equals to 7 times 10. Okay, so we can substitute 50 by 5 times 10 and 70 by 7 times 10. We'll get that 90 minus X over X equals, instead of 50 I will write 5 times 10, and instead of 70 I will write 7 times 10. Okay, here we have 10 in the numerator and we have also 10 in the denominator, so we can cancel 10. Or we can reduce this expression by 10 because we have 10 in the both in the numerator and in the denominator. Okay, so after we cancel the 10, we'll get that third equation, that 90 minus x over x equals to 5 over 7. Okay, we cancelled 10, so we have 90 minus 6 over x equals to 5 over 7. Okay, so now we'll multiply both sides of the equation by 7. We'll get that 7 times 90 minus x over x equals to 5. Again, 5 divided by 7 times 7 equals to 5, and 90 minus x over x times 7 equals to 7 times 90 minus 6 over x. Now we'll multiply both sides of the equation by 7. I explained to you already that it is allowable because x actually equals to AP. It is a positive number, it can never be 0, so it is allowable to multiply both sides of the equation by x. So we'll get that 7 times 90 minus 6 equals to 5 times 6. Again, we multiplied 5 by x, so 5 times 6 equals to 5x, very simple. And 5 times 90 minus 6 divided by x times 6, x is cancelled because we have x both in the numerator and in the denominator, so we left with 7 times 90 minus 6. Now we will open the brackets in this side of the equation. We will get that 7 times 90 equals to 630, and 7 times minus 6 equals to minus 7x, all equals to 5x. Okay, so we open the brackets. 7 times 90 equals to 630, and 7 times minus 6 equals to minus 7x. Okay, all equals to 5x. Now we will add 7x to both sides of the equation. We'll get that I repeat, 630 minus 7x plus 7x equals to 630, and 5x plus 7x equals to 12x. Here we will divide both sides of the equation by 6. So we divided both sides of the equation by 6. 630 divided by 6 equals to 105. And 12x divided by 6 equals to 2x. So this is the third equation, but we have already defined that AP equals 2x, okay? According to our definition, AP is equal to x. So I will add the fourth equation that states that AP equals to x. Okay, according to our definition, AP equals to x. So if AP equals to x, then 2 times AP will be equal, or 2 times x will be equal to 2 times AP. Okay, very simple. And we have from the third equation that 2 times 6 equals to 105 units. This is the third equation. 2 times 6 equals to 105 units. Okay, so we can combine the fourth equation and the third equation together. We'll create the fifth equation that states that actually 2 times 6 equals to 105 from the third equation, but according to the fourth equation, 2 times 6 also equals to 2 times AP. Okay? According to the third equation, 2 times x equals to 105, but according to the fourth equation, 2 times x equals to 2 times AP. So we can write here that 2 times x equals to 2 times AP according to the fourth equation. Okay, so actually we got the equality that 2 times AP equals to 105 units. Okay, so this is the last step. We actually found out that 2 times AP equals to 105 units. Okay, this is the final answer to the question, that 2 times AP equals to 105 units. Okay, from the fifth equation we have the equality that 2 times AP equals to 105 units. Okay, so the answer to the question, find 2 times AP, is that 2 times AP equals to 105 units. Okay, so now I will summarize the lecture. So we actually wanted to find the value of 2 times AP, or the size of 2 times AP. We have in the question the sides of the value of the sides of triangle ABC. Side AC equals to 70 units, side AC equals to 70 units, side BC of triangle ABC equals to 50 units, and side AB of triangle ABC equals to 90 units. So, and we have a circle. The center of this circle is P, and P is situated on side AB of triangle ABC, and we have two tangents to this circle. The first tangent is side AC is tangent to this circle at point O, and also side CB of the triangle ABC is tangent to this circle in point E. Okay, so actually we connected points P and O together by a straight line, and PE is actually the radius of the circle, and we also connected points P and E together, and PE is the radius of the circle, because it exists from the center of the circle and ends in a point that is on the circle. Okay, for this reason P and also PO are the radiuses of this circle, and we have actually a rule that states that in any circle, the radius in any circle, the radius and the tangent to that radius are perpendicular to each other. Okay, so in this circle, AC is tangent to the radius. So according to this rule, PO, the radius, is perpendicular to AC. For that reason, angle POA equals to 90 degrees, and also angle POC will be equal to 90 degrees, because in any circle the radius and the tangent to that radius are perpendicular to each other. For that reason, those two angles are equal to 90 degrees. And for the same reason, radius PE of the circle will be perpendicular to the tangent to the radius, to CB that is tangent to the radius. And for that reason, also PEB is 90 degrees and PEC is also 90 degrees, because in any circle, the radius and the tangent to that radius are perpendicular to each other. So this angle is 90 degrees and this angle is also 90 degrees. Okay, so, and we also defined the AP as X, so PB will be equal to AB minus AP, that is to say to 90 minus X. So AP equals to X and PB equals to 90 minus X. And we define that angle BAC will be equal to alpha, and angle ABC will be equal to beta. Okay, and we actually then we focused in triangle OAP, that is right triangle because this angle is 90 degrees, and in triangle CAM, that is also right triangle because this angle is 90 degrees. So in the right triangle OAP, we know that sinus alpha equals to OP over AP, and in triangle CAM it is the same in the right triangle CAM, also sinus alpha equals to CM over AC. Okay, so in total we got that sinus alpha equals to OP over AP, that equals to CM over AC. But we know that AP equals to X, OP equals to R, and AC equals to 70 units. This is given us in the question. So we can put this data in the equation, that OP over AP equals to CM over AC, and we will get that R over X equals to CM over 70. This is our first equation, and we will do the same thing in the other side of the equation. So for the first equation we got that R over CM equals to X over 70. This is for the first equation, and from the second equation, or from the other side of the triangle, we have angle beta. We defined ABC, angle ABC as beta, and in this side of the triangle we will focus on triangle BPE, the right triangle BPE, and on triangle BMC, that is also right triangle. So in triangle BPE, the right triangle BPE, sinus beta equals to PE over PB, and in triangle BMC, the right triangle BMC, sinus beta equals to CM over CB. Okay, so in total we have that sinus beta equals to PE over PB, that equals to CM over CB. Okay, but we know, so we can write again this equality, that PE over PB equals to CM over CB, and this will be our second equation. But we have already know that PE equals to R, PB equals to 90 minus X, and CB equals to 50 units. It is given us in the equation. So we will put all this data in equation 2. We got that R over 90 minus X equals to CM over 50, and at the end we got from the second equation that R over CM equals to 90 minus X over 50. But from the first equation we know that R over CM equals to X over 70. So we can create the third equation that states that R over CM equals to R over CM, and we will substitute this side of the equation R over CM by the value of R over CM from the second equation, that is to say 90 minus X over 50, and we will substitute R over CM from this side of the equation by the value of R over CM from the first equation, and R over CM from the first equation equals to X over 70. So in total we will get that R over CM equals to 90 minus X over 50 equals to R over CM for the first equation, that is X over 70. The value of R over CM from the first equation is X over 70, and the value of R over CM from the second equation is that R over CM equals to 90 minus X over 50. Okay, so R after we have this equation, the first equation that is only it has only one variable, that is x. We got that 2x equals to 105 units from one side, but we also know that AP equals to x. So 2 times AP equals to 2 times x. Okay? 2 times, if x equals to AP, 2 times AP equals to 2 times x. And we, from the third equation, we got that 2 times x equals to 105. So we'll create the fifth equation that actually states that 2 times x equals to 105 from the third equation. And from the fourth equation, we know that 2 times x equals to 2 times AP. So we can add it to the fifth equation, and the final equality is that 105 equals to 2 times AP, or 2 times AP equals to 105 units. Okay, so this is our final answer to the question, that the value of 2 times AP equals to 105 units, or the size of 2 times AP equals to 105 units. Okay, thank you very much.